Ladies and gentlemen, good evening and welcome to another session of Nambane Academy Grade 11 Physical Sciences, and we are currently running a series of lessons under Redox reactions. Let me just maybe check how everybody is doing. Bonolo Matosa, how are you, lady?
I'm fine, fine, thanks, and how are you, sir?
I'm doing very well. Neo Mudiana.
I'm fine, and how are you, sir?
I'm doing well. His Majesty, His Excellency, Mr. Nyoko.
I'm good, sir. Thank you
Thank you
for
very,
asking.
thank you very much. Ratanang Pehlo. VC.
I'm good, thanks, and yourself, sir.
Thank you very much. Ladies and gentlemen, Katlego Maritz, how are you, lady?
I'm fine, thanks. How are you, sir?
I'm doing very well. Ladies and gentlemen, as per the agreement, I don't intend on keeping you long. Not because of I want sessions to be short, only because of there's nothing more to be done. That's the thing. At this time of the year and the rate and pace that we went into or we used in our previous sessions, especially term 2 and early term 3, it gave us, we pushed the topics that we say they are more complex and they take a lot of time. So this topic, we started it yesterday, we are going to finish it today. And it will be now the end of paper 2. Then what does this mean? It means we are actually done with the curriculum of the year. Things that we are going to do in term 4, I think we have done them already. Things that completes paper 1, I think they are done already. So hence I said earlier on, the strategy is the reverse classroom style. So in simple essence, when I finish today, you should be done with the curriculum. You can take whatever document you have and tick and check which one was not done. The reason for that is we are going to go back doing revision, ladies and gentlemen. The revision will be based and focused on the probable mistakes that we did in term 1, term 2, that now hampered us to achieve at the desired level. Ladies and gentlemen, when you have time, just send me a message of the topics that individually so that you feel that maybe we should do more or go back to this one. I am still aware that you are still struggling with Newton's laws, electrostatics maybe here and there, and electricity. That is now, choose your topics that you know that you are not so comfortable with. How am I going to do that? It's very easy. From my side, I will do now a program to say this day we will do now electricity, we will do electrostatics depending on your demand. Remember, the program is to assist you. If you feel that you have challenges in 3, just type 3 and then I will see where I can be able to squeeze that. Because next week already, the grade 12s are writing their paper 1. So I want to dedicate the whole of next week to the grade 12s. Only because remember, for them it's more or less a final paper sort of. It contributes to their SBA. So next week the chances are we might not have grade 11 class at all, but I will see where I can somehow steal some time for a session to be there. Hence I want to emphasize that just be on the lookout that today we are actually finishing the curriculum, and I'm so happy because this means we can go back, correct, fix, improve, and expose ourselves to high level of questions that are more difficult in order for us to actually perform well. Ladies and gentlemen, without wasting any time, let's get now into the redox reactions. I explained what is oxidation and what is reduction, and how the word redox came about. It came from combination of the reduction reaction as well as now the oxidation reaction. So the combined two, we call them redox reactions. But what is this redox again, ladies and gentlemen? It is just now a transfer of electrons. So in acids and base, we explained that we are interested in the proton transfer. That is now the H plus. With redox, ladies and gentlemen, we are interested in the transfer of electrons. That is the reason why when an examiner asks us to define oxidation, they will say words like define oxidation in terms of electron transfer. Sorry, then we must be able to say oxidation is the loss of electrons. The examiner can also say now define what is a reducing agent. A reducing agent is a substance, ladies and gentlemen. It is not a process. Oxidation, reaction. Reducing agent, substance. So if you do not have the word substance in your explanation to say a reducing agent is a substance that loses electrons, we will not be able to give you marks. Some questions will come up and ask which substance is oxidized, which substance is reduced. So a reducing agent is oxidized. An oxidizing agent is reduced. Other questions might come to say, define oxidation in terms of the oxidation number. So we say oxidation is an increase in oxidation number. So there are four possible ways of a question coming up on how to define oxidation and reduction. Loss of electrons, reducing agent, substance that is oxidized, and the fourth one will be an increase in oxidation number. All those, I'm referring only to oxidation, is the same for reduction. All those, ladies and gentlemen, they represent oxidation reaction. Very, very, very important and critical to understand. Now, yesterday I showed you that we will always have our reducing agent on the right. Okay, sorry, on the left. And we'll also have our oxidizing agent also on the left. So what does this mean? This means that if I have A giving A plus electron, and then I have B plus giving now also plus E, giving out now B, it means now I can do what we call the net cell. What is this net cell, ladies and gentlemen? The net cell is the overall reaction. This reaction here will be our reduction reaction. This reaction here will be our oxidation reaction. And note, ladies and gentlemen, I'm only using one arrow. I will explain as we move. So it means I will be able to say A plus B plus will give me A plus B. Okay, there's an A plus there. So where am I going to look for my agents? Reducing agent as well as oxidizing agent. Where am I going to find that now if I am given a net cell? Those I am looking at my left hand side. But how will I know now between A and B which one is a reducing agent, which one is a oxidizing agent? Ladies and gentlemen, we use now the information of increase in oxidation number. From plus 1 to 0 of B, it means we have a decrease in the oxidation number. So when we are given a net cell, that is very, very important to be on the lookout for. I have a cheat sheet that I use. I will share that cheat sheet very soon. And very soon, it's now, let's look at this table. This table is called table 4P. I want to emphasize, ladies and gentlemen, this table is called table 4P. There is table 4A and this table 4P. Please, ladies and gentlemen, use table 4B. People will use table 4A, but the confusion that comes with table 4A, it's the confusion that now makes us to lose a lot of marks. Let me give you your 30 seconds to digest everything in this table. Please, if you have it somewhere next to you, just open it up. I'm going to explain everything here. This table is very, very critical. And this topic also overlaps to grade 12. So I'm doing it in detail such that you are able to use it in an exam. You also have now a predetermined skill on how to use it. Thank you very much, ladies and gentlemen. Let's get into explaining this table. Let me use red for purposes of emphasis. Ladies and gentlemen, let's start. This side with an up arrow refers to increasing ability or let me just say so that it sounds nice, increasing reducing ability. What does this mean? This means it is a reducing agent. And while it is a reducing agent, it loses electrons. And then when it loses electrons, we say it undergoes oxidation. Let me remove this line. I don't think I need it. But now there is a catch. The ones at the bottom, will be my weakest reducing agent. The one at the top will be my strongest reducing agent. So what does this say, ladies and gentlemen? It says everything. I'm going to highlight and delete everything on the left hand side of the arrow here, everything on the left hand side of the arrow, it is our reducing agent. Ladies and gentlemen, I repeat, everything on your right hand side, it is a reducing agent. Very, very, very important. But now, yes, they are all reducing agents. And when all of them are reducing agents, the one at the bottom, or when I move now from bottom to up, I'm actually increasing what I call the reducing ability. What is the reducing ability? Is the ability to lose electrons. So the ability to lose electrons increases ability to lose electrons, increases from more positive to more negative E naught. Now I am introducing another complex situation or concept. The concept that I am introducing is now the concept of E naught. Ladies and gentlemen, what is E naught? E naught is what we call the standard reduction potential. Some people call it EMF. This is just the value, ladies and gentlemen, that indicates the ability to lose electrons. This is just a value that we are going to use. If you check for hydrogen, there, it is now 0 for everything. So what are we doing? We are using a standard potential of hydrogen as now what? As a reference point. Hence the statement that if you are more positive, you will be able now to attract electrons more. The ability to lose electrons increases from positive to more negative. That means if I move from down here where I have a +2 moving towards the negative, it means what? The ones at the top, let's look at lithium there. Lithium will lose electrons easily. Why, ladies and gentlemen, it is more negative compared to everything that we have. It is at negative 3,05. But if I was going to compare it with Mg of 2,3, negative 2,36, which one will lose electrons more? Good question. They are both negative, yes, but which one will lose electrons easily? Ladies and gentlemen, it is the one that is more negative. The one that is more negative will lose electrons. So it means lithium will be now a stronger reducing agent than Mg. His Excellency, input please.
Sir, I'm still trying to keep up and understand.
Thank you very much. Now Mudiana.
So far I understand.
Thank you very much. Ladies and gentlemen, let's move. Let me copy or highlight everything here for the purpose of me moving it somewhere there so that now I can explain the right hand side. Oh, sorry, the left hand side. The left hand side, we'll use purple for this one. We have a similar situation. And what is a similar situation I am referring to is that at the top we have our weakest oxidizing agent. At the bottom we have our strongest oxidizing agent. So where are the oxidizing agents? Where are they? Everything on the right here except the electrons. Everything on the right here must be our oxidizing agent. So on your right, reducing agents. On your left, oxidizing agents. So when you are asked in an exam to identify an oxidizing agent, ladies and gentlemen, it must be on the table and it should be on the left. If you choose anything else, you are definitely lost. Let's now delete this. And do the same. But this time I'm just going to say, as you move down, let's use blue again, or purple. When you move down again, very easy, gains electrons. What happens also? Increase in oxidizing ability. And what happens again? Basically says gains electrons. It increases in oxidizing ability. So the more positive you are, you have now the ability to force other substances to lose electrons. That is how you are gaining electrons. Let me repeat. The more positive you are, you have now the ability to force other substances to lose its electrons. Or let's say more positive E naught, comma, indicate where electrons can easily be absorbed. Let me put in bracket gained or transferred. Gained or transferred. So if I am more positive, I'm able to attract electrons. I'm able to gain electrons because my valency orbitals are empty. So it will be easy to fill it in with now what? With the electrons. Remember, ladies and gentlemen, electrons are negatively charged. So if I am more negative, it means I have excess electrons that I can be able to donate. But if I am more positive, it means I have protons. I don't have electrons. So for the purpose of neutrality, I will need to gain some electrons. A few electrons must be transferred to me as what? As an oxidizing agent. Now, ladies and gentlemen, I have said a mouthful about this table. Now we are deriving a cheat sheet. Please follow. It's important we do so. Ladies and gentlemen, we have what we call the C method. A C method is an analogy that allows us to say reduction maybe I must just write it here. Reduction and then oxidation. What does it mean? The one at the top is oxidation, the one at the bottom is reduction. Simple as that. And how are we going to write our oxidation half cell? We are going to write it from right to left. How are we going to write our reduction half cell? From left to right. Because we are writing that C method. The example I made of lithium and Mg, if I was going to write or use my C method, it will come like this. What will it mean? They are both negative, ladies and gentlemen, but I need to identify oxidation and reduction. Which one will lose more electrons? Which one will gain electrons, even though they are both negative? But remember, we said now as we move up, we are increasing the reducing ability. So the ability to lose electrons. So the question will be between negative 3,05 and negative 2,36, which one is more positive? 2,36, because we are moving towards 0. So it is more positive. So the one that is more positive will gain electrons. The one that is less negative, more negative, it will lose the electrons. But by just using the C method, we are able to say definitely at the top here I'm going to have oxidation, and at the bottom here I'm going to have my reduction, regardless of which substances I am now referring to. Katlego Maritz, inputs please.
So I understand. No complaints from my side.
Thank you very much. Neo Mudiane.
Sir, I understand so far. No problems, sir.
Thank you very much. VC.
I'm following, sir.
Thank you very much. Ladies and gentlemen, everything has been explained in detail. The only thing that will be left as part of the exercises that must come, basic concepts have been taught. Basic concepts of oxidation and reduction, how to identify possible type of questions that one must expect in an exam. With all this combined with now the table, says we are done in terms of explaining the redox reaction for grade 11 learner. So the curriculum of that is done. What do we need? We need to understand how now the examiners are asking these questions. What are the possible mistakes that we are going now to be faced with. Ladies and gentlemen, let me go back to this one. I want to steal this table as raw and clean as it is, and then I'm going to cut one and then paste it this side, because it will be given in a formula sheet. I'm going to refer to it as my formula sheet when we do this particular problem. Let's get straight into it without wasting any time. Oxidation numbers makes it easy to determine whether an element is or a substance is oxidized or reduced. Already, ladies and gentlemen, from this one page summary, if a substance is now oxidized, it is a reducing agent. What is a reducing agent? Is a substance that loses electrons, but the process of losing electrons is called oxidation. So already in your mind, in your map, you must have all this lined up. Furthermore, it says now define the term oxidation with reference to the oxidation number. So the examiner wants us to explain defining in terms of the oxidation number. They do not want in terms of electron transfer, in terms of one being oxidized, in terms of a reducing agent also. They are only interested in it in terms of the electron, the oxidation number. So hence I said it is always best for one to be able to identify oxidation according to those four systems we have. So this one is easy. It is just oxidation is an increase in oxidation number. And this, ladies and gentlemen, it will be your 2 marks, 2 or 0. Now from grade 10, these two, grade 10, calculate the oxidation number of chromium in Cr2 O2 07 2 minus 912. So kindly just go back a little bit in grade 10 to actually see what and how you identify the oxidation numbers. I think I also have a session on my YouTube channel. You can just maybe refer to it in terms of the oxidation numbers. It's grade 10 work. So I have 2Cr plus now 7 oxygen. This is equals to 2 minus or minus 2. And this will be easy. This is 2Cr plus 7 multiplied by minus 2 is equals to minus 2. Doing the mathematics, you find chromium here is equals to a plus 6, and this is just 1 mark. 912 or 3. The oxidation number of oxygen in that, you have 2 of H plus now 2 of O is equals to 0. Y is equals to 0. This is now a neutral substance or compound. Let's just say substance is equals to 0. The oxidation number of hydrogen is 1 plus 2 of oxygen is equals to 0. You do the mathematics, then in this instance oxygen is equals to minus 1, then also just 1 mark, 100%. Now this is where I want us to be. Consider the unbalanced equation below. Fe2 plus Cl2 gives us now F3 plus and plus Cl minus. Ladies and gentlemen, this is where now the trick of oxidation numbers comes in. This is the trick where the table can also come in. Remember, we said whatever I do, this side I am going to get my agents, and agents we said is your oxidizing agent or your reducing agent. But before I can assign which one is reducing, which one is oxidizing agent, what must one do? There are so many ways of killing a cat. The first one is I'm going to check the oxidation numbers. Oxidation is an increase in oxidation number. So I am moving from 2 to 3 plus. So definitely iron is moving from 2 plus to Fe3 plus. Ladies and gentlemen, definitely now that means there's an increase in oxidation number. Cl 0 is moving into Cl minus. So this is my oxidation species, and this must be my reduction species, only by using the oxidation numbers. But furthermore, I have a table 4b that is given to me. Let's try and make it large and see if it's going to assist. Let's try to find Fe2 plus. Fine. Fe2 plus, ladies and gentlemen, Fe2 plus, there it is, thank you. We'll just highlight and delete afterwards. Let's highlight. F2 plus is there with 0.77. Now we must find Cl2 in the table. Cl2 is there, ladies and gentlemen, with plus 3.6. Can we also use the C method to confirm? Let's see if the C method will apply. The C method says when I move from top to bottom, at the top I'm going to have oxidation, and at the bottom I'm going to have reduction, and is exactly what is happening here. So let me just, for the purpose of not going back, I'm going to have Fe 2 plus moving into Fe 3 plus now 1 electron. And remember, we said we write now our oxidation from right to left, and we write our reduction as it is. So I'm going to have Cl2 plus 2 electrons giving me Cl minus. I just want to write this just for the purpose of me not going back to the table again. So that is the reason why, ladies and gentlemen, we need the table, because now the table assists in identifying also the number of electrons and also identifying your oxidation and reduction potential. So we have already done this. We know this is oxidation. We used two methods, one from the table, two from the increase and decrease in the oxidation number, and this is now reduction. So when I have these two, they look like something that I know, ladies and gentlemen. Then it's easy to say, let's not answer the question first, but let's put emphasis on saying, it basically says this one here must be my reducing agent, and this here must be my oxidizing agent. Then I am ready to answer the questions. I've actually answered all the questions. I'm just going to write it neatly for each and every one of us now to follow. Let's go, ladies and gentlemen, and do this. We are now at 921. Define the reducing agent with reference to an electron transfer. A reducing agent is a substance that loses electrons. Easy 2 marks. 2 or 0. 9 22 922. The formula of the reducing agent, ladies and gentlemen, we have identified that Fe 2 plus. Remember, we need to have now the indication of ions, because the indication of ions also indicates the electron transfer. 923, the oxidizing agent, they want the formula. Ladies and gentlemen, we have answered that already, Cl2. So 1 mark, 1 mark. Ladies and gentlemen, the oxidation half cell, the oxidation half cell, we have written it, is the one at the top, 924, or reduction, sorry, reduction, it's Cl2 plus 2 electrons giving us now Cl minus. 925, oxidation half reaction, it's now Fe 2 plus giving us Fe 3 plus 1 electron. Now, ladies and gentlemen, 926, there's a little bit of a challenge. The question says, write down the balanced net redox reaction. What are we balancing here? Ladies and gentlemen, we only balance the electrons. I must put it here. Only balance the electrons. But how do we balance the electrons? Let's multiply this one by 2 and that by 2, this by 2. Then we have the same number of electrons, so these electrons will cancel with that. Let's write the net cell. The net cell is something like 926. It's 2Fe 2 plus Cl2, giving us 2Fe3 plus now Cl minus. Ladies and gentlemen, that is now how one can approach these redox reactions in detail. So everything here has been done, the explanations thereof. Honestly, one when looks at this can easily say it is important and imperative for one now to yes, 100%. I'm even lost out of words, colleagues, learners, sorry. So we are done with this. I just need now your inputs, please. Let's start with VC.
So it was a lot to take in, but I'm understanding.
Thank you very much. Ratanang Phehlo.
So it was a lot of information to take in, but I think the more that I practice and do it, I'll understand.
Thank you. It's only because it's not yet done at school, ne?
Yes, sir.
Thank you very much. His Excellency.
Sir, I think that I'm starting to like actually understand the work. Yeah, that's all I got.
And you have not done it also at your school, ne?
Yes, sir.
Yeah, no, 100%. Motawa Science 20, any inputs?
Mr. Nambane, good evening. No inputs. Everything is explained into details. Thank you.
Thank you very much, Mr. Mukwena, for your presence into this meeting.